Uniform line charge density is 5 nanocoulombs. Then there's a surface charge density, and we want to find the magnitude of E at the origin. So for these line charges, and you can think these line charges are kind of going like this. This is through all of X, this is Z, this is Y. So this is at -2 meters. 2 meters. And since this is a positive, this is positive 5 nanocoulombs, negative 5 nanocoulombs. So what's going to happen here is we can see that the point is going to see an electric field line like this. And you could just take this one and then double it because it's producing the same amount of electric field. Right? Same thing with this one. This one is positive 0.3 nanocoulombs, and this one's negative. So we know the force is going to go directly down. And again, this is a surface charge. I'm just not drawing the X. It would look something like this. It's an infinite sheet of charge, right? So now let's calculate these. So we know our line equation is this. We know what our unit vector is. Our unit vector is just Z, right? So this is just Z, and we know the distance between the two. So R is equal to 2, R hat is equal to 0, 0, 1, or Z. You just call it Z. So we plug in what we know. This is 0.3 nanocoulombs. I'll just 5 nanocoulombs, sorry. This is 5 nanocoulombs. I'm just leaving out the meters because we can assume that the units work out. This will be 2 meters, and this will be in the Z direction. But one last thing, we need to multiply it by 2, right? Because we have 2 points producing the same amount of electric field. So we just do one problem and then multiply it by 2. It's just to save yourself some time. And that'll equal and you notice I won't get a negative out of this number, but I threw that in anyway because I know I know intuitively by looking at the problem that it's going to go in the negative Z direction, right? Now, E surface, call it E surf, is the equation is this. Not deriving them, just know what direction it is, and we know that this is going to be in the negative Y direction, right? So we just plug in our 0.3 nanocoulombs to epsilon naught, and we multiply it by 2 again because there's 2 surface charges, right? You're just multiplying it by 2 because they produce the same amount. It'll be in the Y direction. These 2's will cancel, and you will be left with 0.3 over epsilon naught in the Y direction, and that will leave you with a negative 33.9 AY. And again, that negative didn't come from the equation, that came from my intuition, seeing that this is a positive charged surface, this is a negative charged surface, it's got to point down, right? So now, finally, we will add the total equals the z component and the y component, so that would be negative. Trying to make that a little neater. Minus 89.9 AZ, and that makes sense, right? Because these are bigger charges. They're the same distance away, but these are bigger charges, so you should see more coming from your point charges. So you should have a larger z direction of electric field. And this would be our answer, but we have to get the magnitude of it because the problem is asking for that. And it's pretty simple to do. You just take these values, you don't even have to worry about the negative signs. And that will leave you with 96.1 volts per meter. And this is also volts per meter. I just left it out because I'm lazy. All right, hope that helps.